Hey everybody, David the AI Guide. How are you? Welcome to another episode. Thanks so much for all the comments lately. We really appreciate that. Comments give us new ideas, and we love having the feedback from our active viewers, and it's great. Also, please subscribe. Follow us on Facebook, Twitter, and Instagram, and support us on Patreon, because a little bit of support will help us add new interviews, go to live events as things start to open up, and do a lot of stuff that we won't be able to do without your support. So I would really appreciate that. Thanks a lot. And today we're going to talk about AI at NASA. We've talked about NASA a number of times, but it's been sort of by inference. In other words, in their articles that they publish, NASA hasn't really talked a lot directly about AI. Every once in a while, but in the vast majority of articles, they have not talked about AI, even though we know that they are using it extensively. And today is an article that was specifically about AI. So one of the big things that NASA does is study the sun. And the reason why is because, as a viewer mentioned very recently, a Carrington event, which I had forgotten. But a Carrington event is a huge coronal mass ejection that sweeps over Earth. And the last major one was in 1859, before the modern age. So this fries all electronics dead. And back then, the only electronics was the telegraph system. And what it did was fried, it was like a huge bolt of lightning hitting the telegraph system-wide, so strong it caught poles on fire. This is like phone poles, same thing. So this was pretty major, and one of these today would be catastrophic. So why? Because our whole society and world is run by electronics. And if all of that stopped working instantly, chaos would ensue. So this is one of many reasons NASA studies the sun, to understand its dynamics, to be able to start to predict when large flares or coronal mass ejections, CMEs, are going to happen. So there's a bunch of brand new solar satellites cruising the solar system to study the sun. But there's one called SDO, Solar Dynamics, that has been around since 2010, so it's 11 years old. This is before Parker Solar Probe and the ESA's new probe that is on the way to the sun right now. And this SDO takes images of the sun in ultraviolet light. And most satellites do a particular kind of light, like the new James Webb Space Telescope is an infrared telescope. But in ultraviolet, they can really see a lot of the detail of how the atmosphere moves and changes and evolves on the sun. And SDO looks at 10 different wavelengths of ultraviolet light every 12 seconds. So as you can guess from what I just said, the amount of data being downlinked from SDO is huge, huge. And as they try and understand the sun better and better, the amount of data starts to get overwhelming. And so NASA started to look into better ways to manage the data, number one, but even more importantly, these solar satellites like SDO and Parker Solar Probe and the new ESA one, because they have cameras looking directly at the sun, they get out of calibration very, very quickly. And in the past, NASA was using sounding rockets to send up test subjects that they could use to calibrate the satellites, SDO specifically. So they would send a sounding rocket up, which is a suborbital rocket. It never reaches orbit. And they would use Parker Solar Probe images and images from the sounding rocket and compare them. And then they could see how much out of calibration the cameras on SDO were. Sorry, a minute ago I said Parker, but SDO is what we're talking about. So this can only be done every once in a while, once every 1 or 2 years. And NASA was trying to think, how can we continuously calibrate these cameras so that they don't get out of whack now that they're going to have 3 of them up there, right, between SDO, Parker, and ESA. NASA and ESA work very closely together now and share all data and scientific results. In fact, NASA openly shares all of the results of their various satellites. But anyway, back to the topic at hand. So by using machine learning, they were able to build an algorithm to train this algorithm to look at SDO's images and understand when they became out of calibration. And the way they did that was by feeding the algorithm with thousands and thousands and thousands of images, some of which were perfectly calibrated, some of which were out of calibration, and the algorithm learned the difference and how to fix it. So this is a breakthrough. This keeps the cameras on SDO and then Parker perfectly calibrated all the time instead of getting a lot of image degradation over time and before they could send up these sounding rockets. So this type of technology, by the way, will apply to all of the satellites out there and telescopes studying the universe. This will include eventually Hubble, and it will include the new James Webb, which is launching October 31st. This is the most sophisticated, largest space telescope ever launched, and it's going to be launching very soon, 3 months. So machine learning algorithms can keep these complicated instruments in calibration, and this really helps scientists get better and better results and be able to publish scientific studies more often because the results are more accurate all the time. Very powerful stuff. AI will play a big role going forward in accelerating science. It already is, but this is a very clear and specific example from this NASA article of that happening. Hopefully, I will be interviewing some folks from NASA in the near future. I'm working on that. So click the link below for our free resource to learn more about AI. It's a beginner's resource. You don't have to know anything, and it'll teach you a lot more about AI, much more than we can in terms of technical stuff in these short videos. And also, like, subscribe, share on YouTube, follow us on Facebook, Instagram, and Twitter, and please consider supporting us on Patreon. We really appreciate it. Take care. Have a good day.